So in this slide, both the radial jet and then a tangential jet are shown together so that you can appreciate the difference. The jet is hitting at this point, and the circle shown over here in yellow color is known as pitch circle. And it hits the wheel rotates like that. Right? This is tangential flow. For this circle, the jet is tangential. Now here there are two circles, yellow circles are shown. The jet is coming in at this point, and then at this point it is going out. So entry and exit are at different distances, whereas here entry and exit are at the same radial distance. That is a major difference one should make out. In tangential flow, the inlet and outlet are equidistant from center of rotation, whereas in radial flow, the entry point and the exit point are at different radial distances. Why it is called radial? The actual jet is this way. It will be having component towards the center of rotation, a radial component, and then another component will be tangential component. Okay. Schematically, the same information is shown here. So this is the tangential inflow, right? This is the top view of the blade. You can see here enlarged isometric view of the blade is shown. The entry of the jet, and then it hits and then goes that way. Exactly front view it will be something like this. The velocities will be one behind the other. So this is the case of tangential flow, whereas here it is radial flow. The outer blue circle is entry circle, entry point, and then red circle shows radius R2 where the jet is going out. So R2 is the distance of exit, R1 is the distance of entry. Here in tangential flow, both entry and exit are at the same radial distance. So this is tangent flow. Note the orientation of the vanes, how the vanes are arranged with respect to the wheel. The angular speed is omega. The angular speed is omega. So in front view, the entering jet overlaps the leaving jet. The entering jet will be overlap and exit jet. The jet looks tangential to the wheel. The jet looks, it will be coming like this, so it will be tangential to the wheel. Both the jets, that is entry and exit jets, are at the same radial distance r from the center of rotation. Hence, the linear velocity of this point u will be given by r omega. U is equal to r omega. So this is the picture of radial jet. Note the orientation of the vanes. The vanes are slightly different here. The jet enters here and then goes out there. In the front view, the entering jet and leaving jet on an average will move radially, that is towards the center of curvature. So entry tip and exit tip of the vanes are at different radial distances from the center of rotation, R1 and R2. Corresponding linear velocities U1. So if it is going this way, U1 is the radial, tangential velocity. U2 will be the velocity there. So U1 will be given by R1 omega. U2 is given by R2 omega. So at the entry point and then exit point, the vane velocities are different in radial case. So in total, in both tangential and radial cases, the velocity triangles look similar, but in tangential case it is the top view, whereas in radial case it is front view. In tangential case, u1 is equal to u2 is equal to u, which is given by r omega. In radial case, u1 is r1 omega, u2 is r2 omega. This makes a difference in analyzing the work done and efficiency in tangential flow case and radial flow case. Okay, thank you.